K2 Algebra, Mr. Berta here. Let's do some practice problems where we divide rational expressions. So why don't you follow along this video? I'm going to do problem 3A, and then try 3B on your own, and then watch the next video to check your work. Okay, I'm looking at problem 3A here. And the first step I want to do is convert this from a division problem to a multiplication problem by multiplying by the reciprocal of that second rational function. So I'm just going to rewrite the problem as follows. 1 over x squared plus 9x times, and here's where I'm taking the reciprocal of that second function. All right, so now I've rewritten it as a multiplication. So here, I'm just going to go ahead and now I'm going to try and factor. I'll focus first on the numerator. Right, so in the numerator, I've got the 1 out front here. So I'm just going to keep that. And then I've got a 3x squared minus 18x. That's right, we've got a greatest common factor here, right? The greatest common factor there is 3x. When I factor out 3x from 3x squared minus 18x, I'm left with x minus 6. And there, we are now done factoring the numerator. And this 1 out front, I'm actually just going to erase it, since we don't need that. And I accidentally erased the 3. There we go. So now let's focus on the denominator. Here we've got x squared plus 9x. That's right, we've got another greatest common factor, and this time we can factor out an x from that factor. When we do that, we're left with x plus 9 inside the parentheses. Okay, and then our last term is 6 minus x. All right, the 6 minus x term is actually quite interesting, because if I know, let's see, if I take 6 minus x, I know that's equivalent to -1 times x minus 6, right? If I multiply -1 times x, I get negative x. And if I get -1 minus times a -6, I get plus 6. And if I switch the order of those, I have 6 minus x. So I know those are equivalent. And I actually like the format of this one better because it matches with what's already in the numerator. So I'm going to rewrite this denominator. We'll keep the numerator the same. We've got 3x times x minus 6 for now. We'll keep writing the denominator, the first part of the denominator. But then the second part, I'm going to swap out the 6 minus x for a -1 times x minus 6. All right, and the reason I did that is because now it comes time to go to the simplification step. Let's simplify. I see that I have x minus 6 in both the numerator and denominator. I also see that I have a single x in the numerator and denominator. And that leaves me here now with a 3 in the numerator, a -1, and an x plus 9 in the denominator. All right? When we have a -1 in the denominator, we can also write that up in the numerator as well, or we can write it out front. What I'm going to do is I'm just going to combine it with the numerator, and so further simplify this answer to -3 over x plus 9. That's a format that I'd like to see for the simplified quotient of this problem. Now we're asked one other thing, and that's to find the restrictions on x. So for that, I need to go back to the factored form here. And I need to find out what values of x are going to make that denominator equal to 0. So I'm going to clean this up a little bit and ask myself, if this x out front, well, if that's 0, that will make the whole denominator 0. What about this x here? Well, if that's -9, this second factor will become 0. which leads to a 0 denominator. This -1, well, there's no value of x that can make that 0. That's always going to be -1. But here, if x is 6, this factor will also be 0. So I know that x cannot be 0, -9, or 6. So I'll write that all in one line here. X cannot be 0, -9, or 6. And those are your restrictions on the variable x in this quotient.